Direct variation. So direct variation is a type of linear relation, and it always runs through the origin. Okay? And that means that its x-intercept and its y-intercept are always equal to 0. Okay? Intercept. Okay? It can be written in the form y equals kx. Don't ask me why they chose k. If you remember slope intercept form, y equals mx plus b, where b is the y-intercept. Basically, because the y-intercept is always 0 in a direct variation, we're just erasing that. Okay? Basically, that's what we're left with, except we use k instead of m to represent the slope. Alright, constant of variation is basically the slope. Okay, it's the amount that your independent variable, or your dependent variable, is going to change for all the change that your independent variable makes. Okay, if I increase x by 1, y is going to change by 1 times m. Alright, and again, the constant of variation in this form should be k. Alright, identifying direct variation from equations. So if you can write it in that form, y equals kx, that direct variation form, it is a direct variation relation. Alright, this is a direct variation. It has the y isolated, and that is equal to 3x. Right? You got your constant of variation right there. It's 3. It is also your slope. Okay? An easy way to look at it is if there aren't any constants other than a 0 that's being added. If there's no other constants that are being added or subtracted from the variables, and it doesn't fall into one of those special cases like square roots or taking the variable to a power, it's going to be a direct variation. Okay? Because if you can put it in that form, you basically have that plus 0. Right? That plus 0 saying that my y-intercept is 0. And if my y-intercept is 0, my x-intercept is 0, it's going through the origin. Right? Let's look at those special cases. Just as a reminder, they're the same as when you're looking at linear functions. Okay? If you have the variable in an absolute value, it's not going to be a direct variation, and it's not going to be linear. If you have your variable in the denominator of a fraction, either variable, it's not going to be a linear equation or direct variation. If you have your variables to a power other than 1, right, because if I have my x to the 1 is the same as just x, but if they're taken to another power, it's not going to be direct variation. If you multiply your variables together, it's not direct variation. And if you take a root, okay, square root, cube root, any root of your variable, it's not going to be direct variation. Okay? So if you're looking at a equation, right, a relation, and you see anything weird like these, it's automatically not going to be direct variation or linear. Okay? If it looks fairly normal, then you need to start looking to see if there is an added or subtracted constant. Okay? So if we look at the non-examples, we have a number over here. Okay? If I have a number over here, when my values, if I have a number, not 0, opposite of my variables, it's not going to be direct variation. Because when I move my x over to try and get it into that y equals kx form, I'm going to be left with a plus 7 in this case, okay, or a plus number, and that's not going to be direct variation. Okay? Here's another one. Actually, I have 2 added constants, right? 2 and 3, not going to be direct variation. This one can be a little trickier because it looks like they're all connected to the x, but when I distribute them out, it becomes 6 over 3 plus x over 3, and I can't have that because even though it's a fraction, it's another constant. Okay, so that's not going to be direct variation. And then this last one, pretty similar to the one above it. Once I distribute the 2 times 4 and 2 times negative y, I end up with 8 minus 2y equals 17x.
Teachers, please come check your...
And because it doesn't have, or because it does have that extra constant there that's being subtracted from 2y, or that 2y is being subtracted from, it's not going to make a direct variation equation. Okay. If we look at our examples here, these are all good. I can divide this by 2, divide this by 2, but basically if I have any situation where I have something multiplied by y and something multiplied by x or divided by x, it's going to turn out to be a direct variation equation. Okay. The other situation is if I have something, if I have both variables on one side and I have a 0 on the other side, that'll work because when I move my x over or I move my y over, the 0 is going to basically disappear. Right? It's not going to impact me. Okay. Another one that's slightly different. I have multiple variables. Okay, but those will get added together, and I'll end up with just the 2 terms. One term with y in it, one term with x in it. And then the last one here, I do have an exponent, but it is only on a constant that I'm multiplying by a variable. So this will also fit a direct variation equation. All right, let's look at a couple examples. In this one, again, I have my 2 terms with variables in it, and my third term over here is a 0. So since it's not a constant, when I move one of my variables over, it's going to disappear, and I'll be left with a direct variation equation. Okay. This one, you can easily see I have a constant that I'm adding to my variable, so this will not be a direct variation equation. All right. This one looks a little more complicated. A lot of times people struggle with fractions, but remember I can write this 4y divided by 5 in the same way that I do with my x variable here. I can write 4/5 times y equals 2/3 times x, and that is going to be a direct variation equation because I don't have any constants that I'm adding to my equation, and I'll be ending up with a equation that runs through the origin.